So, all right, we're live, class. All right, and then get ready for the chat. I will bump around here and ask you to put answers on the chat just for fun, and I'll mark it on the, your participation, I guess. What does participation mean? I don't know. Just make it more fun for you and make it interactive. Okay, GCF. It looks like, you know what? I'm just going to go ahead and show the answers. And if you guys, and I want you to know that too, on the homework Kudo worksheet, page 1, here's some of the notes that I inserted. Here's the notes that you see. And then here's page 2. Okay, so we can just check ourselves. Did we get this right? I had them do these during the taking of attendance. So, greatest common factor, 8 goes into all 3 of these. And then when we look at the x's, there's an x to the fourth, third, fourth, third. So third can be taken out. Y to the fourth, fifth, third, fourth. Third is the lowest power on the y, so that means that's the minimum that you can take out. And then just making sure you get what's left over there, okay? Good to go on that. This is why this one's different. All right, maybe I'll do a step or two, and then here's the answer. Like I said, you were supposed to kind of do these during, hopefully you had enough time, but we're going to move on. So I could take out a 5a squared. And by the way, before I continue, I should look for a GCF. Ooh, 25, 5, 10. So far, 5 goes into all 3 of these. Wah, wah, wah. 5 doesn't go into 2. A squared, no A, no A. H, no H. Done with the H's. F, F, but 2 others are missing in F. So there is no GCF. You should always look for that first, though. All right, now that you don't have a GCF, then a different scenario happens. 5H, and then what's left over is F. And then plus, in this one, you have a 2Y that is in common. And then you end up with, again, 5H minus F. The only way grouping works is if this and this are the same, all right? So that's why you see this pulled out as a binomial GCF, and then when you pull that binomial GCF out, this is what's left over with that one. Okay, next one. Just wanted to throw this one out there because it is a 1 in front, so it is an MA, and you just got to make sure that the last terms have a V on it. Good FOILers, good factors. Okay, U times U is U squared. 6V times negative 10V is negative 60V squared. And then, yes, you do get the middle term. That's what the point of another reason why I say good FOILers, good factors. They check their answer, that it makes sense. Then this one, you do have a negative 5 that you take out. And I would not, negative 5, this is 4p squared. I probably would not use the trick. And you do want to take out a negative because you do want a leading positive coefficient. Oh, couldn't say the words there. So that it's easier for the factoring next. So definitely a negative taken out. All right, what do we have in the middle term? 5, 10 goes at 16. Is that 16? 5 times 16, but it's minus. All right, and then minus 9. Okay, maybe it might be tough, but I know for a fact, you know what, I'll just do the trick way. All right, 4 times negative 9 does equal negative 36. And then A equals negative 9. Hey, I think in the review and or the test, we have a question like this that we break it down step by step using the cheating method. I'm sorry, not cheating, the this trick method. Hey, what multiplies to negative 36 and adds to the negative 9? Who's going to be first on the board here on the chat? What multiplies to negative 36, the same two numbers add to be negative 9. I'll pause the video depending on how long this tube. Brianna in period 2 got the numbers. Negative 12 times 3, negative 12 plus 3. All right. So 4p squared. What do you do with that? You break up the middle term. Wait, let me make sure. Negative 12 times 3. I got to pause the video for a second. I feel like there's a mistake somewhere. And I don't know what I'm doing, YouTube. Holy cannolis. The middle term is negative 16. I don't even know where 9 came from in my head. Sorry. Reboot. Back to the chat. M is the multiply of 4 times negative 9. A is the middle term. I don't even know where negative 9 came from. But I knew I had a mistake because negative 12p plus 3p doesn't equal 16 negative p's. So there was a problem there. Reboot on the chat. What multiplies a negative 36 and then the same two numbers add to be negative 16? Ay, caramba. All right. Mr. Samuels hopefully cleans up his stuff here from here on out. It's negative 18 and 2. Ay, ay, ay. And I'm going to write the 2 second because there's a problem with minus signs. You've got to make them plus negatives when you are, doing this type of factoring. In the first set of terms, and I'm going to group them maybe with a different color. I take out a 2p, and I'm left with 2p minus 9. This one, you want to take out a 1 just so you see it, because there is no GCF other than 1, I guess, is the best way we can say that. And then you can see how you get your final answers here. You take out a 2p minus 9 out in front here, even though it's written second. And then what you're left with is 2p plus 1. Okay, good deal. And make sure in your final answer, you don't forget about the original GCF you took out. That's a common error. Okay, going to take a breath here for a second. Okay, back online, back on the video for period 2. Here we go. So nice little review. I don't know if I had pretty standard questions here. These look scary, but if you just calm down, look for a GCF first and then see what's left over. No, I don't think, this doesn't factor by grouping anymore. You could try it. They have a y as a like term, and I do want to cover this. 4x plus 5y, and then you could group this. This is plus a negative, and group these two terms. And the only thing you could pull out of that is that maybe a negative 2. So then this would become 2x minus y. This is why grouping, or this is unfactorable. These are not equal. Not equal. So there's nothing to pull out as a GCF. So what I'm saying is, just because you have 4 terms doesn't mean it factors by grouping necessarily. Not everything is factorable. All right, even like these, just because I have a trinomial, let's just throw hopefully I accidentally, x squared minus 3x plus 1, nothing multiplies to 1 and adds to negative 3. So this is unfactorable. And that happens, and hopefully it did happen in your homework a time or two. So just be aware of that. Sometimes just isn't going to be factorable. Okay, now, I forgot I was in the answers. All right, so I did pull something from the book. You don't see this on the note sheet. I added this today just because I wanted to show what we are going to be doing today, all right, and show what they have. Now, the perfect square trinomial, excuse me, perfect square trinomials, we can actually factor that by MAs and not really worry about this being a special case. But if you want to go ahead and write this down in a couple that they use as an example, go for it. It is a trinomial, and I'll show you an example, and I'll scan down. And what ends up happening is it factors to be a plus b times a plus b, or a plus b squared. A binomial times itself. Here, I'll give you a for instance, and I'll use what they use out of the book here. Let's just focus on this and then not make a big deal out of it. See, it is a trinomial, and it is in the form x squared x constant, and it's very simple. A would work for this, but then it gets a little bit more complicated, and this is why you're going to want to recognize patterns. So, of course, what multiplies to 64 is 8 times 8 and 8 plus 8. So it factors to be x plus 8 times x plus 8, or x plus 8 squared. And hopefully you see that. And then they just show another example. What if it's a negative middle term? Well, then it's just x minus 8 times x minus 8. Very similar question, but you have a negative middle term. So factoring by MA would be just fine for something simple like this and not really have to worry about memorizing a special case. But then you get questions like this. And I would go ahead and write this underneath the trinomial, perfect square trinomial is, I believe, what they call that. Yep, perfect square trinomial. So go ahead and write this as your first official example of a complicated, trinomial square. And what are the attributes of it? Well, just be careful, but that is a perfect square, the first term, and the last term is a perfect square. But then remember what we do. Good FOILers are good factors. We're going to try to factor this through what the relationship is that I've demonstrated here, and then check, does our answer make sense? So what's the pattern for this? Well, let's check, is this a perfect square trinomial, meaning is it a binomial times itself? And what that binomial would be is the perfect square of the first, because good FOILers are good factors. Boom. Yes, that'd be 49x squared. And does it end with the perfect square of the last? But identifying that my middle term is negative, these would both be minus 10s because negative 10 times negative 10 is a hundo. All right. And then does that give me a middle term that matches here? Negative 70x and negative 70x. So yes, this followed the pattern of a perfect square trinomial. All right. Now notice why this is a big deal, and you may think, oh yeah, that's easy. What if you didn't think first that you might have a perfect square trinomial? You'd start doing MA. Holy cannolis. MA is 4,900. Oh, that's a big number. 49 times 10, 100, I mean. And then A equals negative 140. That's a big number. Oh, wait a minute. Negative 70 and negative 70. Negative 70 plus negative 70, negative 70 times negative 70. And then once you see this, you should stop and say, hold on, this is a perfect square trinomial. Let me see if the perfect square of the first and the negative perfect square of the second, sorry, I didn't put a square there, ends up being a binomial times itself. All right, I'm going to stop the video for a second. Any questions? All right, so what I'm saying is it is tough when you have factoring, like for a chapter test, because you have to look at the question first, analyze what you have, and then use your method. So hopefully we can identify perfect square trinomials. Then, I love this one. Actually, sometimes we call this dots. Difference of two squares. Dots. And it takes the form of this. Little different than the first one, perfect square trinomials. And it's very simple to prove this. A times A is A squared. This is negative AB. This is positive AB. And then this is the difference here, minus B squared, not plus the last term squared, minus the last term squared. Then these middle terms fall out. Good FOILers are good factors. Foiling, factoring. They are reverse operations of each other. And then the example that they give you, I think it's the same numbers, isn't it? No, they did a little different. I was hoping they would, yeah, I could actually do it with this one. X squared minus 64. Similar to the last question, but wait, there's a missing middle term. Well, that's because this one's a little different. It's not x minus 8 squared. It's x minus 8x plus 8. X squared, negative 64. Drop the middle term. Good FOILers, good factors. Oh, I'm going to save forever. Because I still get people that don't get the connections with factoring of the good foiling, good factoring kind of thing. So it is a problem. All right. You want to write those couple examples down, go ahead. This is just for like identification. All right. I have a difference and I have two perfect squares. So yes, x plus 6, x minus 6, or x minus 6, x plus 6. We know multiplication's commutative. That is the correct word. Then this one just demonstrates, hey, always look for a GCF first, then factor second. And then I did this on purpose. I made this one up, and I want to show this how it's different than this one. This has a middle term, and the last term is positive. This does not have a middle term, and there's a minus in between. So is this a difference of two squares? 7x is the perfect square of 49. 10 is the perfect square of a hundo, but it's plus minus or minus plus. Don't care who you write first. Good FOILers, good factors. 49 x squared, negative 100. That's why we need the opposite signs. Middle term is crushed. 70x and negative 70x. All right? All right. Pause for a second, take a breath. Whew. I should have put that in the video, my complaining about the kids these days. Okay, now I'm going to go to the notes before I do the next one. So this is and resides in 2.7. So we do have a couple scenarios here. Look at 5 and look at 6. And go ahead and just look at it here if you don't want to look at it on the sheet that you might have in your computer screen. Notice this one just has two terms. This is what you have to do in a smattering of a whole bunch of factoring questions. You got to analyze, what do I have? I have two terms, and it's a minus. So this looks like dots. And then simultaneously looking at this one, I have three terms. Oh, and I don't have one as a leading coefficient. This is what I was talking about on, how would I recognize a trinomial squared? Well, usually when they get complicated, the m number gets extremely large. Like, oh man, 25 times 16. This is going to be a really tough MA analysis. Wait a minute. Hold on. Mr. Samuel said when m is very large, it's possible I have a special case. Possible. So let's check. Oh, all right, wait, that is a perfect square. Does this work? Does this possibly be 5b here and 5b here? And then this is a perfect square, but we have a middle term. And the middle term is positive. And 16's perfect square is 4 and 4 plus plus. Is this right? Well, let's see. 25b squared, of course. Positive 16, of course. 20b and 20b added together is 40b. Darn tootin'. This is a trinomial perfect square, meaning it equals a binomial squared when factored. Then I'm going to go back over here. Yes, I have dots with only two terms. First of all, in all cases, 5 goes into this, 5 goes into this, 5 doesn't go into that. No GCF. So I forgot to do that with number 6. Is there a GCF for this? Yes or no? Okay, we'll hold off on that. Is there a GCF for this particular question? Boom. Yes. Excuse me. Always look for a GCF first. Okay, so I have that GCF pulled out. And by the way, this was a difference of two squares as is. And if you would have factored it as a difference of two squares, you just would have had GCFs in both the factors. And you are required to take them out after the fact. So I'm going to take it out first. Then, all right, I still have a perfect square and a perfect square. Question myself, is this right? Plus minus or minus plus. Let's check. 4x squared, negative 9, destruction of the middle term. Sweet Georgia Brown. I'm erasing that question mark because I'm locking it in. All right, so brand new thing here. Okay, and then in your book, this is why the homework is a worksheet instead of the book. This is honors, and we wanted to extend it to questions that are not quite just x squareds, x and constants. The variables, are a little bit larger, but still fall in the format of, the two special cases. So let's just think of it that way. So holy cannolis, x to the sixes and y to the sixes. First of all, is there a GCF in number 7? Put it on the chat. So yes, in the chat, we got a 4. And then, okay, is this a difference still of two perfect squares? Because we have a difference, and I have two perfect squares. Well, let's check. What's the perfect square of x to the 6th? Won't put it on the chat. It is x to the 3rd. X to the 3rd times x to the 3rd equals x to the 6th. Really shouldn't have to write that down. Hopefully you have minimal knowledge of exponents there for us to know that. And then what's the perfect square of 16y to the 6th? 4y to the 3rd. And again, this being new to you, this pattern, is this right? Difference of two squares? I'll put minus first this time and plus because it doesn't matter one way or the other. X to the 6th, negative 16y to the 6th, destruction of the middle term. The middle terms would be 4x cubed, y cubed, minus 4x cubed, y cubed. You're gone. Okay? So, boom. And then this one. What is the GCF of number 8 if there is one? Put that up on the chat. Should have been waiting to answer that question. Excuse me. So always look for a GCF. I made that mistake in number 6. I didn't look for it before I factored the perfect squares trinomial. And then look at this, how this is different than this. And you know what? Let's change the question. Let's make that a minus in the middle. Just go ahead and do that. You can erase and make it a minus because it's still going to work here. So what did we say? 3 is the GCF. And then look at what results. 25. No u. U to the 6th, u to the 3rd, no u. V to the 3rd, v to the 6th, no v. So there is no variable GCF. And then 3 goes into, and I changed that to a minus just because. It could be a negative middle term in this pattern or a positive. And then plus 4 v to the 6th. Now, this one you'd survive by doing MA. M equals 100. That's not too big. A equals negative 20. Don't put it on the chat. I think it's obvious that the two numbers are negative 10 and negative 10. Negative 10 plus negative 10, negative 10 times that. Wait, when these two numbers are equal, then I do have a trinomial square. That's another little clue that we can go ahead and do this in a fast factor. So what's the perfect square? And again, question it. Wait, I just learned this. Is this right? So this would be 5u to the 3rd. And then what's the perfect square of 4v to the 6th? 2, oops, whoopsie daisy. Another brain misfire. 2v to the 3rd. Ugh, v's are real shaky here. And I have a negative middle term and a positive last term. The only way that could happen is minus minus. Wait, is this right? 5 u to the 3rd times 5 u to the 3rd. Bam. Of course, negative 2v cubed times negative 2v cubed. Bam. Not a destruction of the middle term. Negative 10 u to the 3rd v to the 3rd. Another negative 10 u to the 3rd v to the 3rd. Boom. Shakalaka. Do write this like this at the end then. 3 times 5u to the 3rd minus 2v to the 3rd quantity squared, because it is a binomial square when you're done. Whew, one more deep breath. So again, a problem, and this is why, today is Thursday and you have a test a week from now. I know it's a 4-day weekend for you guys, but hopefully we're incorporating some, homework aspects there to get ready for this stuff. Because what's tough about the factoring is it's just going to be factor, and you're going to have to decide what method is actually going to go on here. So that can be kind of tough when we're doing it section by section. Then okay, yeah, it's either a difference of squares or it's a perfect square trinomial. But then when you throw it in the grand mix of things, hopefully your practice makes you ready for all these things. all these different possibilities. Because then the last one we're going to throw at you, you feel free to write down what you want, is the special case called a sum or difference of perfect cubes. Now, it will tell you this is going to be like a formula. This is something you're going to have to remember and memorize. So here's how they broke it down. This is in the Math 3 book, unfortunately, so you won't be able to see it in your book. But I think I did give you the Math 3 interactive book. So this is section 2.3, one concept in section 2.3 in the IM 3 book. And I did share that resource with you as well because we are going to leak into that book a little bit off and on throughout the year. Okay, so just for instance, remember, good FOILers, even though this isn't a FOIL, become good factorers. So when we reverse this question, this is why it factors to be the question up above there. So anyway, this is synonymous with doing this, writing it like this. You got to take A and distribute it into the second polynomial. And I'll even go blue because they color B blue. Then I got to distribute B into that polynomial. And then this is what I end up getting when I do that. And then look at what happens. You know, I could actually skip it right here and not have to write that term, but I can put these two together and they cancel. I can put these two together and they cancel. And lo and behold, what I'm left with is a perfect cube plus a perfect cube. So therefore, when I factor a cubed plus b cubed, this is the factorization of it. And they have that written right here. This, consider that a formula. And you're going to want to write that in your notes right now. Stare at it, look at it, memorize it, because that's what a formula is. I'm sure you've heard of the quadratic formula before. Maybe not. Maybe I'm throwing some out at you that you don't know. But let's say equations of lines. You have a formula memorized for what an equation of a line is. Go ahead and put that in the chat. What's the most popular equation of a line? There's actually various answers. I wasn't even, oh no, I wasn't even recording during all this. Oh well, we're doing a sum and difference of cubes, and I just did a whole analysis of breaking down, hey, good FOILers are good factorers. So they show a multiplication of it, and then that means the reverse of that would be factoring. And then ultimately, this is what I had them put in the notes, their formulas. But anyway, what do we use in the shower today? Soap. 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 And then I know this is a big mess over here. I should write this in a different color. Soap. Soap. Interesting. What does SOAP stand for? Same. It's an acronym. It's a trick. Opposites. Always positive. Same. Opposites. Always positive. Soap. So when I have a difference of two squares, the formula, difference of two cubes, the first element is the perfect cube of this. The second element is the perfect cube of that. Same. This term is this perfect cube squared. Opposites. Opposites. This middle term is these two terms multiplied together. And then always positive. This last term is this term squared. That is the formula. Okay, so I'm going to erase these and so they're not, oh, geez. Okay, put that right there. Same. Opposites. Always positive. Nothing to write there. Perfect cube of the first plus the perfect cube of the second. perfect cube squared, the two cubes multiplied together, last perfect cube squared. That's the formula, and that's how we would verbalize it. Alrighty then. Here, I'm just going to do a basic one right under this. So, x cubed minus, you know what? I'm going to do 64 because 64 is special. 64 is a perfect square, 8 times 8, but it's also a perfect cube. Very simple chat question. What is the perfect cube of 64? All right. So does this follow the pattern of a difference of two squares? That's a perfect square. Oh, no, that's a perfect cube. Wait. So this is a perfect cube, and this is a perfect cube. So it's a difference of cubes, not squares. Perfect cube of the first is x. Perfect cube of the second is 4. This squared is x squared. These two multiplied together, this squared. And then now it's time for SOAP. Same, opposite, always positive. And then here's the thing. I know you don't have time to check your answers. Good FOILers, good factors. But when you start doing goofy stuff and make, you jack up what the formula is, then usually this is wrong. But it's not. X times x squared, boom shakalaka. Negative 4 times positive 16, negative 64, boom shakalaka. Okay, do the middle terms fall out? If you have the time, do check that. If you don't, at least check first and last. Because usually when people do something wrong on this stuff, the first and last is not correct. X squared 4x squared. Negative 4x squared. Hasta la bye-bye. And then 16x and negative 16x. Hasta la bye-bye. So yes, if I have the time and it really didn't take too much there, I can check that multiplies to be the question. Therefore, I factored correctly. Good FOILers, good factors, blah, blah, blah. Ooh, x to the 6th. Ooh, x to the 6th is a perfect square. Interesting. Plus. Oh, it can't be a difference of squares then. By the way, I should have put that up with a difference of squares. A sum of two squares does not factor. So that's where was that example here. You're like x squared plus 36, by the way. That doesn't factorable. Or that doesn't factor. It's not factorable. There's nothing you could break down there that makes that a binomial times a binomial. Impossible. Don't say x plus 6 times x plus 6 because that would factor to have a middle term. And this one does not have a middle term. So just wanted to clarify that. But a sum of cubes actually does. Okay, where's it at? Getting there. Patience. Where am I? What just happened? Oh, here we go. Okay, let's see. Trying to think of a perfect, a unique way. Oh, yeah. 125. Hey, and let's throw that old variable on there. Y to the third. Oh, that's a cube. Is 125 a perfect cube? Chat. I know I forgot to turn on the movie explaining that a sum of two squares does not factor, but a sum of two cubes does. So I did the old perfect cube of this, perfect cube of that. First term is this squared. This middle term is these two multiplied together. Last term is that one squared. SOAP, same, opposite, always positive. Okay, now the time to go to the formal notes. I don't know if I'll get to the factoring completely section, but I'll probably just keep blabbering and treat these as note situations. So you just have to listen and watch. And hey, maybe in my blabbering, some people worked ahead, and then you can check yourself if you were right. Perfect cube of this, perfect cube of that. This squared, these two multiplied together, this squared. SOAP, same, opposite, always positive. Check yourself before you wreck yourself. At least do that. All right. A times a squared is a cubed. Negative 3 times 9 is negative 27. I feel pretty confident. Sometimes people put a minus here, on accident because they do the SOAP thing wrong. And this one isn't really hard to check. Do the middle terms fall out? 3a squared, negative 3a squared. Hasta la bye-bye. 9a, negative 9a. Nice. I'm good to go. I'm a good foiler, therefore I'm a good factorer. I know this isn't a foil. I still like saying that term a lot. Take out a 2 before you do anything. 1, 27, a cubed. Cubed, okay. That's a big sign that this might be a sum of cubes when I'm done. Is 1 a perfect cube? Well, of course it is. 1 times 1 times 1. So 2 times binomial, trinomial. Perfect cube of 1, 1. Perfect cube of 27a cubed is 3a. 1 squared, 1 times 3, 3a squared, 3a squared, both the 3 and the a. SOAP, same, opposite, always positive. Check yourself before you wreck yourself. If you don't have the time, move on. At least I feel good that I got the first and the last term. Because again, the biggest mistakes made is usually that last term, they don't put the right thing in there. All right, but anyway, the middle term falls out, and I don't think I have to keep covering that. Okay, I'm going to blabber to the end and have this as a video for you. Remember what I said at the beginning of class. It should have already popped up in your Google Classroom, 2.7 practice. The homework is on the calendar above there as I finish the thing here. It's that CUDA worksheet. It's a lot of questions, but I hope you find that factoring actually becomes fast. So it really isn't that bad. And then I am going to pop a review on later today. That's going to be about 30 questions, and that's due by Thursday before the test. So I'll talk to you again about that on Wednesday because we do have our first official go time test on Thursday next week, a week from today. Okay, so I'm just going to finish this off. And if you know how to do it, you can leave. I know it's 10:07. I'm just going to keep teaching this, keep taping it. And if you wanted to watch the end of the video, right now I'm at, hopefully I could remember this, I am at 38 minutes. Woo! All right, so I blabbered the whole class. But I want a record of this in case you missed something, in case you want to see something again, or in case someone in my next hour is absent. Okay, is there a you wrong. There is a GCF. Those are all even numbers. Oh, I wish it was 8, but 8 doesn't go into 20. 8 goes into these 3, but I think 4 goes in all of them. And then I don't have any variables at the end, so there's no variable GCF. So take out a 4 first. 5u, v minus 2u plus 4 times 20 is 80 minus 4 times 8, right? 4 times 8 is 32. All right, I got to change the colors maybe. When it's 4 terms, you factor by grouping. This is what I mean about you just get a smattering of factoring questions. What's the method? But when you have 4 terms, it's potentially grouping after this. So it may not be done after I simply take out a GCF. 4 times. I guess I'll use brackets now. I can take out a u. 5v minus 2. And I can take out a, looks like a 4 is the greatest common factor of this one. Oh, nice. 5v minus 2. Remember what I said up above. The only way factoring by grouping works is if these two parentheses are equal after that taking out a common term between those two individual terms. And I got my final answer now. I take out that 5v minus 2, and I'm left with u plus 4. So that's what I mean about this is why this is an important section. Hey, which method comes about here? So this next one, feel free to leave. Like I said, I'm at the 39.50 mark. So if you wanted to watch these last three later, go for it. If you get the gist, then just yeah, you're good to go. 6 times 5 is 30, and you want to take out a negative, and there's also a k. So negative 6k, and you're left with 6k squared minus wrong plus 5k. And then 6 times 6 is 36. And it's minus. Sorry, I was thinking for a second. And it is minus 6. Ooh, brain kind of stopped there for a second. Okay. You know what? 6 could be 6 and 1, 2 and 3, and this could be 6 and 1 of them negative, and 2 and 3. My brain's kind of dead right now, so I'm going to go ahead and do that cheating method. I don't want to call it a cheating method. I just wish people would try to avoid it. M equals, because of that 6 there, negative 36. A equals 5. Okay, luckily my brain's firing okay. 9 times 4 equals 36, and they are 5 apart. 9 has to be positive, 4 has to be negative. And that's what a big part of factoring is too, being numerate. K squared plus 9k minus 4k minus 6. Negative 6k, don't forget that. You group, so I guess I'll put this in parentheses here, or brackets. So I group these two, and I pull out a 369 3k. And I'm left with a 2k plus 3. And then that means in the second thing, you have to pull out a negative 2 plus negative 2. And luckily, you are left with a 2k plus 3, which is equal parentheses, the only way grouping works. Final answer, GCF, 2k plus 3 pulled out, GCF again with inside those parentheses, and a 3k minus 2 left over. All right. Going to continue. Ooh, 8, no, 4? 4 going to 50? No, 4 goes into 52. I think I only have a 2. And, oh, a y. That leaves me 4x to the 6th minus 2 from 50 is 25, y to the 6th. Now, this is where this gets a little goofy. Is this a difference of squares or a difference of cubes? Because they kind of look similar. There's only two terms. X to the 6 and y to the 6 are cubes and squares. Oh, my brain's going crazy. But 4 and 25 are squares. So this is a difference of two squares, and we'll prove it. Remember, good FOILers are good factors. 2x to the third, 5y to the third. Those are the perfect squares of each of these. 2x to the third, 5y to the third. And then it's plus minus because, yes, yes, and the middle terms cancel. So I know I'm good. I know that's a difference of squares, not cubes, because 4 and 25 are squares. Then the last one, again, always looking for a GCF. I believe 2 is going to be the GCF. Wrong. 2v. And then we get 64 u cubed. Oh, watch this one. You're going to love this. Plus 125 v cubed. Obviously, we have cubes and a sum. Perfect cube of the first is 4u. Perfect cube of the second is 5v. First term is this squared, 16u squared. Second term is these two multiplied together, 20uv. And then this last one is this one squared, which is 25v squared. Whew. Same, opposites, always positive. Check yourself. Yes. Yes. And if you have the time, That's negative 80 u squared v. This is positive 80 u squared v. This is 125. Oh, I'm sorry, no, that's a hundo. And this is a negative hundo u v squared. So the middle terms fall out. It's a little complicated there, but it really isn't. It just follows a pattern, and then you just make sure you check yourself at the end. All right, done with the video.